Okay, so my FX actually have two parts. And before we get started, I want to say that my English is very bad, so forgive me for saying something wrong or funny. Okay, so let's get started. The first part is this. It's called water geo. So basically, it's just bunches of geometry created with the curve attached to the sword. That's it. The second part is the particle fluid, which is a flip simulation. Come on, man. Yes. Like this here. So basically, this is all the stuffs. So first of all, let me show you how I did this fluid simulation, because this is actually what looks really awesome. Okay, this is just a fill-in. It's just a geometry, no big deal. Okay, so first of all, I have this model geometry, this FBX katana. I don't know how to read that, how to spell that. Okay, I have this downloaded from the Sketchfab for free. Alright, and I did something to scale it down, put it in the right position, and that's it. And then I delete the part which is not the front of the blade. So this is actually my emitter or my flip source, and then blah 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 blah. I give it some noise to destroy the surface, to destroy the primitive, so it's going to have a more random and organic emission from the sword. And then that's it. And then you just do a flip source and cache it down, and that's it. That's all. Next thing, you need to get into the DOP network and create these stuffs. So let me tell you, what did I do? First of all, I source my flip source, of course, here. The surface, the path, all that stuffs, and I gave it a gravity but scaled down version. You see, so it's not going to fall down very fast. It will do this and then gets down. Okay, and then I actually slow the simulation down. It's in slow motion because my animation is in slow-mo too. You can see this. You can see this here. Yeah, just like this. And that's it for the flip simulation. By the way, these stuffs are all generated automatically from the shelf tool. So here we have this mesh thing, this fluid surface thing, and this cache thing. It's very convenient. It's very convenient. I highly recommend you guys use the shelf tool as well. I just did, I don't know, I did this. Yes, I used this shelf tool. And this is the mesh. Wait a second. The mesh, 67 frames. I only cached 2 frames down because it really takes a long time to calculate the meshes. Okay, so now let me show you how I did this weird looking water geo. It's not perfect. I still need to improve it, but it has the shape. Yes, it have that general shape that looks fine for me. Looks fine to me. Yes, and it's animated, of course, animated like this. I think in the Demon Slayer animation, they just draw the water part. It's not computer generated. They draw the water part, so it's very artistic. It's very cool, very good looking. And then they simulate the white water part, which is all the splashy water simulation here. Yes. So I don't really think we can achieve that good-looking water geo with 3D technique, because they literally use their hand to draw it. So we can't compare with that, but we can come very close to that result. So here we go. Basically, this is actually complicated than a lot more complicated than the fluid simulation. So let me show you. It's just here. First of all, the same thing, I just select this and delete everything else, and then I scattered 4 points down here. I don't know if you can see it. 1, 2, 3, 4. And then this is not important. Then I just did this. There's a line, okay? A line here, and I have my 4 points here, and I used this copy to points, so it's going to generate some lines. And you might wonder, why are the lines in the right direction, in the correct direction? Why aren't they pointing to the same direction? How did I get them to point to the direction I want? It's actually very easy. You just need to set up the same up vector. Yeah, use the cross technique, all that, and then you will have a very cool this thing pointing to a custom position you want. Like if I say -10, it's going to point downwards like this. Yes, it's very useful. This thing is very useful, you know. And I just made my normal becomes the up vector I created. And then down here, the copy to stamp node will automatically use that normal as the as the rotation or something, you know. It's going to follow your normal. I don't see any normal here. Yes, it's following my normal, so the directions are all correct. But you might wonder, you might find a mistake here. So if you are in other direction, you might find it's actually doing this 90-degree thing. I don't remember how to say that in English. So it's not in the right direction because your line direction is wrong. So you just need to tweak these stuffs and figure out which one is the right one. Yeah, and that's it. And then I resample it, of course, standard procedural stuffs, just to, yes, and then add some noise to it just to get a more organic look. Holy shit, it looks like the Flash, you know, the CW Flash. And then this is for preventing the intersection, maybe? Is that the correct way of saying it? So if you check this out, wait a second, check this out, you will see before that it's having some intersection. It just come right through the geometry here. So I had this with the normal, you know, with the original normal right here. So the original normal made sure that every line is pointing out instead of pointing inwards. So this normal direction is always pointing out, means it will never have intersection. So I just literally simply lerp these two lines together. So from the starting point, it's not going to have any of this noise-based curve shape. It's only to get from this line. Yes, so we prevent some kind of intersection from in the starting position, yes. So if I don't want it to like do this crazy shape, I can just get it down a little bit. And here, yes, that's it. You just need to tweak it, you know. And you might wonder, how did the software know where is the start and where is the end? And that is the curve U doing its job. Curve U is just a U value, range from 0 to 1 on the curve. See, so here is 1, here is 0. Very easy to understand, right? And then I just did the animation, of course, the knife animation, the sword animation, and then I did this. This is very important. This is the most important part of the water geo. I created 3 shapes and lined them like this, you see. So when I plug this into the curved surface, it's going to generate with the surface path and with the shape of this. So it's like this. It's like having a poly extrude from the shape. Yes, like this. But it will bend over according to the curve shape, you know. Yes. Then you just adjust some. You see, there's a twist here, very interesting one, and you can adjust the scale, this and that, very interesting stuffs. And finally, it's done like this. Yes, and I think the shape isn't complicated enough. So, if you want it to be more complicated, I guess you might want to create more shapes. You see, like I have 3 of them here. You can do 4 or 5 to make it look more complicated. And this isn't my idea. This is actually from. Let me search for that. From this YouTuber, from this guy. Yes, he had this idea, and I achieved this thing in the Houdini. Yes, that's it. Thanks to this guy. Okay, so now let me show you the most important part of all. That is the shading. The shading is very important. Everything else can just do, you know, randomly, but the shading really needs to be precise and careful. So I use the Arnold Toon shader, which is a 2D shader here for all the stuffs like the sword, the water geo, and the water. Okay, so let's get to render view and check it out. Like if I use the camera 3, I'll see this result, which is very cool. But how did I achieve this? Let me show you. And first of all, I think we need to check out the water geo first. So particle fluid, bye. Let me refresh it. Yes, like this. So first of all, you need an edge effect. Water itself. Edge effect is here. You just click that on, and you will have those black edge, which really sells an impression of hand drawing stuffs. You see, so let's turn that on. And sometimes you might find out it's not going to do anything because it requires this filter. So where do I enable that filter? In here, in the Arnold RAW. node here, and you just go to output, sample here, and you change this pixel filter from whatever it was to this filter. Yes, and then you get that edge thing. And I did some ramp with the base tone map, and this basically is saying that what will the color be? What is the color in different brightness? You see? So this is the brightest point, and this is the darkest point. So that's it. I hope you understand me here. So if the light coming from this direction is very strong, it's going to make these areas white. But if I change it to some red color, they will be red. Yes, and that's it. That's the basic idea. And that's it. That's all it takes to shade the water geo. There's something more. I gave it some kind of a specular effect, so it's going to have some very cool shiny surface here. Yes, and the blade also have the specular. And then it's the water, the particle fluid water shading. So let me get in here, and you'll see, wow, very, very, very complicated sim. Okay, so how did I do the simulation shading? It's actually the same technique. Yes, I did this tone map, but I want most of the water simulation to be white, because it's actually white water, right? These are the water itself, and these are the white water. So white water should be white. So I did this. I just move everything here, and then I did something else. I used the curvature here to give it some kind of a emission effect. So I calculate the curvature and plug it in the emission channel here. So it's going to control the intensity of the emission. And that's it. That's actually it. So these areas are actually emitting lights, but it's in 2D, so you can't really see any difference. But that's it. So it's going to have more layers, you know, because I have white here, but it ain't white enough. Like these areas are actually the basic color, basic white, and these areas are actually the emission, and others areas like here are the dark part of the simulation. So I made them blue, dark blue, and that's it. That's the whole thing here. So I think the most important thing is to do the texture and of course the lighting correctly, because it really is going to affect how the result looks. So if let's say if I crank this up, this blue light to 6, everything is going to be brighter. Maybe, yes, you can see everything's a little bit brighter, I think. No, not really. So if I do this, I have this white ambient light, it's going to lit everything. Yeah. So the direction and the intensity of the light really matters to the look of the whole thing here. So this is a different result from previous version, because everything is is brighter because of this light, you see, and that is actually also very cool. And you can see if I turn this off, it's going to be even darker, because the main light isn't on. Yeah, it's very different. It's very different. So the light really matters, and that's it. Thank you for watching, and see you next time.